Now we'll start the reduction to canonical form. In previous class we have done the classification of second order partial differential equation. এখন আমরা reduction to canonical form যে কিভাবে আমরা ক্লাসিফিকেশন করার পরে একটা PDE কে আমরা বিভিন্ন canonical ফর্মে রিডাকশন করতে পারবো সেই বিষয়টা আমরা আলোচনা করব এখন. So here the first recall 1. So this is basically steps for reducing hyperbolic equation, into its canonical form, So here let us consider the hyperbolic equation. Let the given semilinear second order PDE, RR plus SS plus TT plus f of XYZ PQ equals to 0 be hyperbolic type. That means that is here is square minus 4RT, that discriminant. This is basically greater than. That means we are doing the case 1. Case 1 নিয়ে কাজ করছি. এখানে একটু দেখে নেওয়া যাক what is the meaning of R. This is basically del 2z del x square, or you can say zxx. The meaning of S is del 2z del x del y, or you can say zxy, and T is del 2z del y square, that means zyy, and is P equals to del z del x and Q equals to del z del y, and Z is basically function of x and y. So two independent variable x and y, and Z is the dependent variable. So now in that case, if the semilinear second order PD is hyperbolic, then how to reduce the second order PD to the canonical form? So here step 1, what we will do, we will find out two characteristic root of the equation. So find two characteristic roots of the equation R lambda square plus S lambda plus T equals to 0. And this is a quadratic equation in lambda. So it has two roots. Say the roots are lambda 1 and lambda 2, say. And in that case, since s square minus 4RT greater than 0, so here your observation lambda 1 not equals to lambda 2, and both are real number. So that means here the characteristic root are basically real and distinct. This is a simple observation that we have done in previous class. যদি এটা হাইপারবোলিক হয় তাহলে দেখা যাবে যে দুটো রুটই ক্যারেক্টারিস্টিক রুট এটা রিয়েল হচ্ছে এবং ডিস্টিংক্ট হচ্ছে. Next step 2, then from that we can find out step 2, we'll find out the characteristic curve. Next find the characteristic curve. characteristic curve. So one is eta and another one is xi. So we'll find out the characteristic curve. Xi and eta. Xi, so this is equals to some function of x and y, and eta, this is another function of x and y, where f1 xy equals to c1 is a solution of linear PD dy dx plus lambda 1 equals to 0, and f2 xy equals to c2 is a solution of dy dx plus lambda 2 equals to 0. Now we'll come to step 3. When এটা হয়ে গেল, then তোমরা step 3 তে move করবে. Step 3 is find PQRS and T in terms of xi and eta, and put in the equation, and put in the equation 1. What is 1 here? This equation is 1. The semi-linear second order PD. This is a basically hyperbolic type. Equation 1, that means RR plus SS plus TT plus function of x, y, z, PQ equals to 0. We get del square z, del xi, del eta. That will be a function of xi, eta, z, xi, z eta, which is the required canonical form. Which is the required canonical form. Okay, or you can, if note, if zxy that transform to say omega xi eta, then the canonical form will be del square z. In position of del square z, you will see the del square omega del xi del eta. This is equals to f xi eta omega and omega xi omega eta. Okay, now we'll solve one important problem related to the hyperbolic type. Okay, so So reduce the equation, problem 1. This problem is very important. Reduce the equation del square z del x square equals to x square del square z del y square to canonical form. To canonical form. Now how to solve this kind of problem? Okay, first we'll check it is hyperbolic or parabolic or elliptic type or not. That we will check. So the given second order semilinear PDE this is del square z del x square minus x square del square z del y square equals to 0. So comparing the given PDE, comparing the PDE with RR plus SS plus the standard form plus fxyz pq equals to 0 to what we get? We get r equals to the coefficient of del 2z del x square. This is basically 1. S equals to coefficient of del 2z del x del y. This is basically 0. And t is basically minus x square. Now we'll check it is basically hyperbolic or not. So now the s square minus 4rt. What is the value of this expression? So 0 square minus 4, 1 minus x square. So this is basically 4x square. And this is greater than 0. So that means it is the given equation, therefore the given PDE, that means 1 is of hyperbolic type. So first আমাদের এটা চেক করতে হবে এটা হাইপারবোলিক টাইপ অর প্যারাবোলিক টাইপ অর ইলেকট্রিক টাইপ কিনা, তারপরে আমরা according to step we can proceed. So it is matched exactly, it is hyperbolic, so that means we can move, we can use step 1 step 2 এইভাবে আমরা step 1 step 2 ইউজ করতে পারবো. So first we will find out the root of the characteristic equation. So this is called the characteristic root. So now we'll calculate the characteristic root. So step 1, this is all about characteristic roots. So we'll solve this equation. R lambda square plus s lambda plus t equals to 0. So here your r is 1, s 0, t minus x square. So 1 lambda square plus 0 lambda minus x square equals to 0. So that means lambda square equals to x square. So that implies lambda equals to plus minus x. Okay, so these are the characteristic root. So therefore the characteristic roots are lambda 1 equals to say x and lambda 2 this is equals to minus x. Now step 2, what we will find? We will find the characteristic curve. See here the characteristic curve that we need to find. So characteristic to find out the characteristic curves. And for that, what we will do, we will solve dy dx plus lambda 1 equals to 0 and dy dx plus lambda 2 equals to 0. So that implies dy dx plus x equals to 0, and here dy dx minus x equals to 0. And we can easily solve it. So dy dx equals to minus x. Here dy dx equals to x. So here dy dx is minus x, that means dy equals to minus x dx, and the other side dy equals to x dx. From that, y equals to minus x square by 2 plus c1, and here y equals to x square by 2 plus c2. So here y plus x square by 2, this is equals to c1. c1, c2 are arbitrary constant. Here y minus x square by 2, this is equals to c2, where c1, c2 are arbitrary constant, while c1, c2 are arbitrary constants. So therefore the characteristic curves are given by, one is f1 xy, this is equals to y plus x square by 2, and another is f2 xy, this is basically y minus x square by 2. So what you consider, so therefore eta xy, therefore xi xy, that we can consider as y plus x square by 2, and eta xy, that will be y minus x square by 2. You will see here, so the characteristic are xi and eta. So xi equals to f1 xy and xi eta equals to f2 xy. Okay, so this is basically our characteristic curve. Now we'll choosing the independent variable xy to xi eta. So next step 3. Step 3 is here. Step 2. Step 3. We will change our PQRs in terms of xi eta put. Okay, so what we will do for step 3 is choosing independent variables xy to xi eta, and then let zxy transformed to omega xi eta. Okay, so that means we will transform zxy to omega xi eta, where xi is function of x and y, and eta is also function of x and y. Okay, so here we have the surface, say zxy. Okay, so this is z x y axis, and we have given the transformation in that way. so that the surface is like this. This may be omega of chi eta. So here this is chi eta and omega. So this transformation. To reduce it in the canonical form, we have given the transformation. So now we will calculate del omega del x. So that will be del omega del xi del x plus del omega del eta del y. Sorry, del x. And okay, so here you will do the rough calculation. So what is your xi and eta? So xi xy, this is equals to y plus x square by 2, and eta xy, this is basically y minus x square by 2. So here del xi del x, that will be x, and del xi del eta del x, that will be minus x. So from that we can write x del xi del x del omega del xi minus x del omega del eta. Similarly, we will calculate del omega del y, that will be del omega del xi del y plus del omega del eta del y. Okay, so now what we will do, we will calculate here del omega del y, this will be 1, and del eta del y. So it will be del omega del xi plus del omega del eta. So we have calculated omega x and omega y. Now we will calculate del 2 omega del x square. Del 2 omega del x square. So that means del x of del omega del x. So that means del x of, what is del omega del x? X del omega del xi minus x del omega del eta. X del omega del xi minus x del omega del eta. And from that, what we will do, that will be del omega del xi plus x del 2 omega x del omega del xi plus x that we can write del xi del omega del xi del xi del x plus del eta del omega del xi and del eta del x minus del omega del eta minus x del xi del omega del eta del eta del x plus del eta del omega del eta del eta del x. Okay. From that, what we will write? That will be del omega del xi plus x del 2 omega del xi square x plus del 2 omega del eta del xi del eta del x, it is basically minus x minus del omega del eta minus x del 2 omega del xi del eta into x plus del 2 omega del eta square minus x. So here the value will be x square del omega del xi square plus x square del omega del eta square minus 2x square del 2 omega del xi del eta plus del omega del xi minus del omega del eta. In similar way, when you will calculate del 2 omega del y square, similarly del 2 omega del eta square del y square, that will be del y del omega del y. So when you will put value del y of del omega del y here, del omega del xi plus del omega del eta, del omega del xi plus del omega del eta, and here you will calculate, that will be del 2 omega del xi square plus del 2 omega del xi del eta plus del 2 omega del xi del eta plus del 2 omega del eta square. So here this value will be del 2 omega del xi square plus 2 del 2 omega del xi del eta plus del 2 omega del eta square. So therefore the equation 1 transform to, here in equation 1 you will see in equation 1 del 2z del x square del 2z del y square. So we have, it is this one and this one. So we'll put here. So therefore the equation 1 transformed to x square del 2 omega del xi square minus 2x square del 2 omega del xi del eta plus x square del 2 omega del eta square. So just you will see the first expression. So this whole thing. Okay. Plus del omega del xi minus del omega del eta. This is left side. This is equals to what is exactly written here. Equation x square del 2z del y square. So x square del 2z del y square. So write this expression here. Del 2 omega del xi square plus 2 del 2 omega del xi del eta plus del 2 omega del eta square. So if we simplify this, after simplification, it will be 4x square del 2 omega del xi del eta. That will be del omega del xi minus del omega del eta. So from that what we will write del 2 omega del xi del eta, this will be 1 by 4x square del omega del xi minus del omega del eta. X square touch. So we need to reduce x square in terms of omega xi. So what is xi xy? So xi xy is y plus x square by 2. Here you will see xi xy is y plus x square by 2 and eta xy is y minus x square by 2. So if we subtract these two, star minus double star, so xi minus eta, that will be 4x square, x square by 2 plus x square by 2. So here x square will be xi minus eta. So therefore that implies del square omega del xi del eta 1 by 4x square. So 4 xi minus eta del omega del xi minus del omega del eta. This is the required canonical form. Therefore the canonical form is del 2 omega del xi del eta 1 by 4 xi minus eta del xi minus del omega del eta. So this is our required canonical form. So here we have solved for the semilinear PDE. We have reduced the semilinear PDE to the canonical form. Okay, and this is one of the important questions here. Okay, so xi minus eta. Okay. Now we will continue the next important reduction to canonical form. This is about the parabolic equation. So now we'll come to the recall 2. Steps of reducing parabolic equation. Steps of reducing parabolic equation into its canonical form. So let the given equation RR plus SS plus TT plus FXYZ PQ equals to 0, this is 1, be parabolic. Be parabolic, so that means that is S square minus 4RT equals to 0. So here step 1 is find the characteristic root. Roots, find characteristic root of the equation R lambda square plus S lambda plus T equals to 0. And here you will see, here you will observe the roots will be real and equal. Here the roots will be real and equal. Why? Because the discriminant is 0. So that is, you will see the roots will be lambda 1 equals to lambda 2 equals to lambda say. And lambda here must be a real number. So what will be the step 2? Step 2, you will find out the characteristic curve. So find the characteristic curve, find the characteristic curves. So one is xi equals to function of xy and eta equals to another function of xy, where fx1 where f1 xy equals to c1 is a solution of dy dx plus lambda equals to 0, and f2 xy equals to c2 is chosen such that the Jacobian del xi eta by del xy, that Jacobian must be non-zero. What will be step 3? Step 3 is put or find PQRST in terms of xi and eta, and you will take the substitution zxy transformation to omega xi eta. Okay. And hence we will see the solution and put in the equation 1. Equation 1 means that equation 1, and we get either del square omega del xi square equals to some function of xi eta omega xi omega eta, or you can see the del square omega del eta square, this is equals to function of xi eta omega xi omega eta. So these are the steps we need to follow here and we'll solve the problem. Okay, so as for example, we'll solve, say, that we'll take one example. Question 2, that question is very, very important. The example is reduce the equation. Reduce the equation y square del to z del x square minus 2xy del to z del x del y plus x square del to z del y square. This is basically y square by x del z del x plus x square by y del z del y to canonical form. To canonical form and solve it. Okay, so these are the problems. So how we'll solve this kind of problem? First we'll check it is parabolic type or not, or hyperbolic type or elliptic type or not. So what are the given PDE? The given semilinear PDE is y square del to z del x square minus 2xy del to z del x del y plus x square del to z del y square minus y square by x del to z minus x square by y del z del y equals to 0. Okay. So comparing it with R plus SS plus TT plus F X Y Z PQ equals to 0, we get, what is our R? R will be y square, S will be minus 2xy, and T will be x square. Now what will be the discriminant? S square minus 4RT, that means 4x square y square minus 4 y square x square. This will be. So that means the given PD1 is parabolic type. So PD1 or equation 1 is of parabolic type. So here we show that it is a parabolic type. So that means we need to follow the steps. We will find out the characteristic root. Then we will move to the characteristic curve. After that we will use the transformation and we will think about the canonical form. Okay. So first step is we will find out the characteristic root. Step 1, all about characteristic root. We know if it is a parabolic type, then the characteristic root will be equal and real. So here r lambda square plus s lambda plus t equals to 0. See what is r? R is y square, s is minus 2xy. So y square lambda square minus 2xy lambda plus t is here x square. X square equals to 0. So that means here we can write y lambda minus x is whole square equals to 0. And from that lambda equals to x by y. x by y. So here the two roots are real and equal. So now we will solve this problem. So therefore the lambda is basically x by y. These are the characteristic root. Now we will find out the characteristic curve. Characteristic curves. Okay. For that, what we will do, first we will solve dy dx plus lambda equals to 0. So that means dy dx plus x by y equals to. Now we will use the separation of variable. So dy dx equals to minus x by y. That means x dx plus y dy equals to 0. So on integration, what we will get? We will get x square plus y square equals to some constant c1, where c1 is an arbitrary constant. Arbitrary constants. Okay. So what about the other characteristic curve? For that, okay, we need to choose a curve. So what is this? Therefore, so we'll consider xi xy. This is equals to x square plus y square. Okay. Now we choose say eta xy. This is x square minus y square. So that the del xi and so we choose this and note that del xi eta del xy, that Jacobian will be non-zero. So what is this? This will be del xi del x, del xi del y, and del eta del x, del eta del y. So del xi del x, that will be 2x, del xi del y, that will be 2y, del eta del x, that will be 2x, and del eta del y, that will be minus 2y. So what will be the value? The value will be minus 8xy, and this is non-zero. So here we can conclude eta is independent of xi. That means they are the independent variables, independent of xi. So now in that, what we have chosen here, this is exactly correct. Okay, we can choose another function so that the Jacobian is non-zero, so that the eta and xi are independent to each other. So now we'll calculate all these. So now we transform that way omega to what we will write. We'll transform here. So we're choosing the independent variable. So choosing the independent variables. xy to xi eta, and then let xi zxy, this is transformed to omega xi eta. Okay, so that is zxy, this is transformed to omega xi eta. So now what we will calculate? We will calculate first here del omega del x. So that will be del omega del xi del x, del omega del eta del x by using chain rule. So now what is your xi xy? This is x square plus y square. And what is your eta xy? This is that we have chosen x square minus x. So del xi del x, that will be 2x, del xi del y, that will be 2y, del eta del x, that will be 2x, and del eta del y, that will be minus 2y. So we put all these values here. So that will be 2 omega x to 2x del omega del xi plus del eta del, this is also 2x del eta del omega del eta. Similarly, the del omega del y, that will be del omega del xi del y plus del omega del eta del y. So del omega del y is basically 2y, so 2y del omega del xi minus 2y del omega del eta. So in that way we will calculate. In that way we will calculate del omega del x square. So now we will calculate del 2 omega del x square. That means del x del omega del x. So del x 2x del omega del xi plus 2x del omega del eta. And if we calculate that, that value will be 4x square omega xi plus 8x square omega xi eta plus 4x square omega eta plus 2 omega xi plus 2 omega eta. Similarly, del 2 omega del y square, that will be 4y square omega xi minus 8 omega square omega eta xi eta plus 4y square omega eta plus 2 omega xi minus 2 omega eta. And del 2 omega del x del y, that will be 4xy omega xi minus 4xy omega eta. So after substitution in 1, all the values will substitute the given equation 1, that equation will substitute all the value here, and what you will get, after substitution in 1 we get 16x square y square omega eta equals to 0. That means we will get omega eta equals to 0. Okay. So this is therefore the canonical form. The canonical form is omega eta equals to 0. So this is the canonical. And that means del 2 omega del eta square equals to 0. And okay, we need to solve. So after on integration, what we will get omega eta. This is equals to some function of chi. Again omega eta, that means del omega del eta, some function. Again on integration, what we will get omega, this will be eta f chi eta plus g of chi, and f and g are arbitrary. So that means what we will get omega xy is zxy. Eta is basically x square minus y square f of chi, x square plus y square plus g of chi is x square. Since omega z and chi is basically x square plus y square, and eta is basically x square minus y square. So which is the required solution? Now we'll come to the third important concept. This is related to the elliptic type. So the next recall 3 all about steps for reducing elliptic equation into its canonical form. So how we will do that? Say let the given equation be RR plus SS plus TT plus FXYZ PQ equals to 0 be elliptic. So first you will check your semilinear PD is elliptic or not. That is SS square minus 4RT, the discriminant is less than 0. So what will be step 1? Step 1, find the characteristic root of the equation. Find the characteristic root of the equation R lambda square plus S lambda plus T equals to 0. And see the discriminant is basically negative. So obviously the characteristic root must be the complex root, the imaginary root. So here the roots lambda, this will be lambda 1 and lambda 2. That are basically the complex roots. Okay, because of the discriminant is less than. So now what you will do, you will find out the characteristic curve. So find the characteristic curves. This is f1 xy equals to c1 and f2 xy equals to c2. By solving dy dx plus lambda 1 equals to 0 and dy dx plus lambda 2, this is equals to 0. So what will step 3? Step 3, let will take xi equals to f1 plus f2 by 2 and we'll consider eta. This is equals to f1 minus f2 by 2i iota, where iota is root under minus 2. Or in some cases we can write here that will be iota by 2 f2 minus f1. Why? Because since 1 by 2i, that we can write minus I by 2. Okay. So here you can show that now find PQRST in terms of xi and eta, and we'll put the transformation zxy to omega xi eta and put these values in equation 1. That means the semilinear, this is equation 1. What we get? We get del square omega del xi square plus del square omega del eta square. So that will be some function of xi eta and omega xi omega eta. Okay. Or you can say in some book, this is the canonical. So which is the required canonical form. Okay. In some book note you will see that is written del square z del xi square del square z del eta square. So this is some function of xi eta z xi and z eta. The same thing. Okay, this is also the canonical form. Now we will continue one important problem related to this kind of elliptic type. So here the problem is basically say reduce the equation, question 3. That question is very, very important in any kind of examination, either graduation or master degree or maybe any kind of competitive level, UGC, CSIR NET. So reduce the equation del square z del x square plus x square del square z del y square equals to 0 to its canonical form. Canonical form. So now first we will check your equation is elliptic type or not. So the given PDE is del square z del x square plus x square del square z del y square equals to 0. So now we'll comparing 1, this is 1, with RR plus SS plus DT plus F X Y Z PQ equals to 0 to we get what will be our R? R will be 1 is 0 coefficient of del 2z del x del y. T is del 2z del y square. So this is basically x square. Now what we will calculate? We will calculate discriminant x square minus 4RT 0 square minus 4. That means minus 4. So less than 0. That implies, okay, equation 1 is of elliptic type. So that means we need to follow the steps what we have written here to reduce the canonical form. আমরা এই স্টেপগুলোকে ফলো করব। So what will be our step 1? Step 1 will find out the characteristic root. For that r lambda square plus s lambda plus t equals to 0. What is r? R is there 1 is 0 tx square. So 1 lambda square plus 0 into lambda plus x square equals to 0. So lambda square equals to minus x square. So that means lambda equals to plus minus iota x. Okay, so now what we will do, step 2 will find out the characteristic curves. For that we will solve dy dx plus lambda 1 equals to 0 and another dy dx plus lambda 2 equals to 0. So therefore lambda 1 equals to iota x and lambda 2 equals to minus iota x. So dy dx plus ix equals to 0 and that will be dy dx minus ix. Dy dx minus iota x equals to 0. So we'll solve it here. If we solve it, so that will be if we solve it, that will be y minus ix square by 2 equals to c2 and that will be y plus ix square by 2 that will be c1. And from that what we can write, we will write x square by 2 plus iy, this is c2 prime, this is equals to c2 c1 prime. So that we can write x square by 2 minus iy, this is equals to c1. So what we can take? So we take say xi, this is equals to x square 2 plus iy, that is considered as c2 and eta xy. You can change it, no problem. You can take the first one is eta, second one is xi. So x square by 2 minus iui equals to 0. Okay. So thus equation 1 transform 2. You just calculate now. You will calculate del. Now you will tweak the substitution omega. In that way you can write here, okay, the choosing independent variable, choosing independent variable xy to xi eta xi eta, and then let zxy be transformed to some omega xi eta. Okay. So in that case you will calculate del xi del x, you will calculate del omega del y, you will calculate del 2 omega del x square, del 2 omega del x del y, and you will calculate del 2 omega del y square. That you will calculate. As previous we have done all these things. And substitute all these values in equation 1. So putting these values in 1, what we get? We get x square omega xi del 2 omega del xi square plus 2x square omega xi eta del 2 omega del xi del eta plus x square omega eta eta plus omega xi plus omega eta plus x square minus omega xi minus omega eta eta plus 2 omega xi eta. That value, the whole thing, that will be equals to 0. So by simplification, what we will get? We will get 4x square omega xi eta plus omega xi plus omega eta equals to 0. So that means omega xi eta, that will be minus 1 by 4x square omega xi plus omega eta. Now since what is xi xy? Xi xy is basically x square by 2 plus iy, x square by 2 plus iy, and eta xy is x square by 2 minus iy. So I need x square, so what I will do here, I will add these two things. Okay, no. We are going to doing some mistakes here. So that we can say the star marks. Okay, we'll think about it later. But what I said here, I said in steps, we'll take xi equals to f1 plus f2 by 2 and eta equals to f1 minus f2 by 2. So what we have done, okay, so in position of xi eta, what we'll do, say we'll let alpha equals to f1 plus f2 by 2 and beta equals to f1 minus f2 by 2i. Or we can put I by 2 f2 minus f1. From that, alpha equals to x square by 2 and beta equals to y. And since f1 xy, this is basically, what is f1 xy? Y plus ix square by 2, y plus I square by 2, and f2 xy, y minus ix square by 2. Okay. So then what we can say here, so then omega xi eta, that will be 1 by 4 del square omega del alpha square plus del square omega del beta square. And what will be del omega del xi? That will be del omega del x del xi, del alpha del omega del beta del xi. From that, what we can write, half del omega del alpha minus I by 2 del omega del beta, and del omega del eta, that will be del omega del alpha del eta del omega del beta del eta, that will be half del omega del alpha minus plus I by 2 del omega del beta. So now omega xi eta, that will be minus 1 by 4x square del omega del alpha. So that means 1 by 4, that will be del square omega del alpha square del square omega del beta square equals to minus 1 by 4 2 alpha del omega del alpha. And from that we can write del square omega del alpha square del square omega del beta square, that will be minus 1 by 2 alpha del omega del alpha. So this is the required, which is the required canonical form. So this is our answer. Thank you so much. In that way you can solve the several problems. You can reduce the semilinear PDE to a canonical form if it is elliptic or hyperbolic.